let's just recap from the video that you were supposed to watch on your own. We're talking about formulas that relate. Guys, you need to stop talking. I'm teaching now. All right, so we're talking about formulas that relate to angles. The first kind of angle is a central angle. And remember, a central angle is an angle whose vertex is at the center of the circle. And the sides of that angle consist of two radii. What do we know about the central angle and the arc that it intercepts? They're the same. So we're going to say angle is equal to arc measure. So if the arc measure is 50, the central angle is also 50. All right, then we went into the category of vertex on the rim of the circle. So remember, I had distinguished them into three categories: vertex on the circle, inside the circle, outside the circle. So it's inside, outside, on, inside, outside, or on. Those are the three things you ask yourself. Is the pointy part of the angle inside the circle, outside the circle, or on the rim of the circle? The first kind of angle is an inscribed angle. An inscribed angle had its vertex on the circle and whose sides are made up of two chords. The other kind of on angle is a tangent chord angle, where one side of the angle is a tangent and the other side of the angle is a chord. And the formula for an on angle is going to be angle equals arc divided by 2. All right, so now we have the central angle, then we have the on angles. Now we have inside, so the vertex is inside, but not at the center. Because if it's at a center, what is it? If the vertex is at the center, then it must be a central angle. So this is an angle that's inside the circle, but not at the center. That's a chord angle. And a chord angle always looks like it's made up of like x's. Made by x's. And in this chord angle, there's a lot of chord angles. 1, 2, 3, and 4 are all considered chord angles. And the formula for any one of these angles is going to be angle equals arc 1 plus arc 2 divided by 2. And the arc 1 and arc 2, arc 1 is the arc that angle's eating. So let's say we're trying to find angle 1. Angle 1's eating this arc. And then arc 2 is the arc its vertical angle is eating. So angle 1 is vertical to angle 2, and angle 2 is eating this arc. So it would be those two pink arcs. Now, if we were talking about 3 and 4, well, angle 3 is eating this arc. And the angle vertical to angle 3 is 4, and that's eating that arc. So depending on which angle you're using, it depends on which arcs you're using. Okay, vertex outside the circle. The first angle we're going to talk about is a secant angle. Yes.
Scroll up just a little bit.
Sure. Like there?
Yeah. Thank you.
You're welcome. And for a secant angle, its vertex is outside the circle, and its sides are made up of two secants. A secant tangent angle, again, its vertex is outside the circle, and its sides are made up of one tangent and one secant. And a tangent angle is an outside angle whose two sides are tangent to the circle. Okay, so the formula for the first two is going to be angle equals big arc minus small arc divided by 2. And the tangent-tangent angle is a special scenario. Does anybody remember what I said in the video about the tangent-tangent angle and its arc? Not the same. Nope. So the angle will be equal to 180 minus the arc. And this only works for the tangent-tangent angle. So what does that mean? If my arc is 100 degrees, then what is my angle? 80. So the tangent-tangent angle and its arc are supplements. All right, are we ready to try some problems? Okay, so first thing we want to do is find angle 1. So I'm going to ask you all, look at the vertex of angle 1. Is the vertex of angle 1 inside the circle, outside the circle, or on the rim of the circle? It's on the rim. So I'm going to write down angle equals arc divided by 2. So angle 1 is equal to arc divided by 2. So now sometimes if you have a hard time identifying which arc it eats, I always consider the angle like a Pac-Man mouth. So what I'm going to do is I'm going to trace Pac-Man and his mouth, and I'm going to see, okay, well, if this is Pac-Man, he's obviously, his mouth are these endpoints right here. So what arc is it eating? Arc AB. So it should be arc AB divided by 2, but do I have the measure of arc AB? Not right now. So then I'm going to sort of look around and I see, okay, well, this angle is 50 degrees. Angle AOB is 50 degrees. What kind of angle is AOB? A central angle. What do we know about the central angle and its arc? They are the same. So that means arc AB is 50 degrees. Now that we know that arc AB is 50 degrees, can I find angle 1? Yeah, so angle 1 will be 50 divided by 2, which is 25 degrees. Now we want to find angle 2. So again, I'm going to look at angle 2, and I'm going to ask myself, okay, angle 2, its vertex, is it inside the circle, outside the circle, or on the rim of the circle? Where is it? Look at the pointy part of the BCD. Inside, outside, or on the rim? It's actually on the rim. See that point C? It's on the rim of the circle. Since it's on the rim of the circle, every on angle has the same formula, arc divided by 2. So now we're going to say, okay, well, here's the angle BCD. Which arc, if it's Pac-Man, which arc is it devouring right now? Julia? BC, you got it. So this is going to be angle 2 is equal to 120 divided by 2, which is 60 degrees. All right, you guys try number 2 on your own. Okay, so for number 2, I'm looking at A, and I see A is an on angle. So I'm going to say, okay, angle A has to equal the arc divided by 2. It helps maybe if you take a different color and you trace the full angle. So angle A is really BCA. Once you trace that angle, you realize it's Pac-Man is eating the 20-degree arc. So angle A is going to be 20 divided by 2, which is 10 degrees. Okay, then we want to go on to erase this highlighting. Then I'm going to go on to angle B. And like I said, it really helps if you highlight the full angles. So A, B, D is angle B. And if you trace that, you realize it's Pac-Man is now eating the 90 degrees. We know angle B, similar to angle A, is an on angle. So we are angle B is equal to arc divided by 2. So angle B this time is 90 divided by 2, which is 45 degrees. All right, now we go on to angle C. Which angle is angle C? Which arc is angle C eating? 90. Again, is that okay? Absolutely. Is angle C still an on angle? It is. So what is it? Arc divided by 2. So angle C, similar to angle B, is 45 degrees. And then lastly, we go to angle B, not angle B, angle D. And when you trace it, you realize that one's eating the 20. And it's an on angle again, which means it has to be 10. How many people got those all right? Great. All right, number 3. All right, so we want to find X and we want to find Y. So I'm going to start with X. X is not an angle. What is X? It is an arc. But now I have to find an angle that corresponds to that arc. Which angle do you think I'm going to focus in on right now? Anybody know which angle? The only angle we have there. What's the only angle we have?
64.
64. Now, this is 64 degrees. Aren't these two angles vertical to each other? So doesn't that mean that this angle is also 64 degrees, even though it doesn't necessarily look like it? Okay, so now I'm starting off with this 64-degree angle, and I'm going to ask myself, this 64-degree angle, is it inside the circle, outside the circle, or on the circle? Inside. My next question for you, since it's inside the circle, is it a central angle? Is it at the center? No. So now I have to use the inside formula. Angle equals arc 1 plus arc 2 divided by 2. So now our angle is not unknown. What is our angle? 64 degrees. So now 64 degrees equals the arc that the 64 is eating, which is X, plus the arc that its vertical angle is eating, which is 100, all divided by 2. Anybody confused with how I got this equation? Okay, so we're using this 64 right here, right? So it's arc 1 plus arc 2. The arc 1 is the arc that 64 is eating. The arc 2 is the arc its vertical angle is eating. So here's 64, here's its vertical angle. That 64 is eating the 100-degree arc. Okay, so now let's keep going. This is simple algebra 1. We know how to solve this. I'm going to multiply by 2 on both sides. So I'm going to get 128 is equal to x plus 100. So x is equal to 28. So we did part 1. I'm going to label it 28 degrees. Now we want to find y. All right, y is an angle, right? I'm going to ask you, is y inside, outside, or on? Outside. Is it a tangent-tangent angle? No. What does a tangent-tangent angle look like? Yeah, like no lines go inside, right? No lines go inside the circle, exactly. All right, so this is an outside angle. So we're writing out the formula. So we know angle y will equal big arc minus small arc divided by 2. So I'm going to trace the full angle for angle y. And now I'm going to see the 2 arcs it eats. What is the big arc that angle y eats? 100. What's the small arc that angle y eats? 64 is a degree. It's an angle, not an arc. It's a small arc. Yeah. 28, good. Divided by 2, right? Aren't the 2 arcs, I'll highlight in purple, this arc and this arc? And we found x to be 28. So now what are we going to do? We are going to do 100 minus 28, which is going to be 72 divided by 2. So angle y is 36 degrees. Yeah. All right. Number 4, AB bisects arc BAC. Follow the letters. The order of the letters matter. B to A to C. This is the arc they're talking about. If AB is bisecting that arc, what is it doing to the arc? Yeah. Good. It's making BA congruent to AC. So these 2 arcs are congruent. Then they're telling us angle 2 is 60 degrees. And we want to find angle 1. So let's go see if we can find angle 1. So we're going to trace angle 1. Do we all agree angle 1 is an on angle? Since it's an on angle, angle 1 is going to be the arc AC divided by 2. The problem is I don't have a measure for arc AC. So I have to find a measure for arc AC. The only thing I know is that angle 2 is 60 degrees. That's all I know out of this whole problem. So I have to start off working with angle 2 and then work my way from there. So I'm going to ask myself, angle 2, inside, outside, or on? Angle 2, inside, outside, or on? On. So then we're going to say angle equals arc divided by 2. But that's 60 degrees. Is it an angle or is it an arc? It's an angle, so that goes here. 60 equals arc divided by 2. Multiply by 2 on both sides. Arc will equal 120. So arc BD is 120. This helps us. Does anybody know why this now helps us? Daniela? 180? 360, because isn't a full circle 360? So now I'm going to do 360 minus 120 and get 240. And then that 240, isn't that split evenly between the remaining 2 parts? So we're going to do 240 divided by 2 and get 120, which means what? All these parts are congruent. So what does that mean for angle 1? Good, I heard it. Who said it? It's, oh, nope, angle 1's not a central angle, so it's not 120.
Oh, it's divided
By 2.
60.
You got it. Angle 1 is 120 divided by 2, which is 60 degrees. Can I go on? Okay, arc CD is 5x plus 6. Arc AB is 2x, and angle AEB is 94 degrees. We want to find arc AB, which is 2x, which means we have to solve for x. Why do you think they're equal? Did anything say those arcs were equal? No, nothing said these arcs were equal, so I don't know that they're equal. So I have to go off of the only real number I have. What's the only real number I have? The 94. What does that 94 belong to? Not an arc, it belongs to an angle. Is it an inside angle, an outside angle, or an on angle? Inside. So now I'm going to write the inside formula. Angle equals, arc 1 plus arc 2 divided by 2. So now the 94, didn't we say that was an angle? So 94 is equal to, all right, so what arc is the 94 eating? 2x. So I know I have to use the 2x. Where do I get the arc 2 from? Mia? Good. It's vertical angles arc. So 94 is eating the 2x. 94's vertical angle, which one is that eating? 5x plus 6. All over 2. So now let's simplify things down. So we're going to get 7x plus 6 over 2. Now we know how to solve this. We're going to go ahead. We're going to multiply it by 2 on both sides. The 2's on the right will cancel. So then we are going to be, what is this, 188? Does that sound right? 188 equals 7x plus 6. Subtract that 6. So we have 7x is equal to 182. 26. Thank you. Now that I know that x is equal to 26, can I find AB? Yeah, it's going to be 2 times 26, which is 54. No, 52. All right, we're going to do this one right here, and then we'll go down to a larger one. Do I want to do this one? Sure, let's do this one. Okay, so here we have circle A, so that means A is the center of the circle. They're telling us angle A is 70 degrees. If angle A is 70 degrees, which arc is also 70 degrees? Good, BD is 70, because the central angle and its arc are the same. What else are they telling us? Arc CD is 120. If CD is 120, which other arc is 120, and how do you know? Good, BD, because they're marked congruent. Now, the only arc I don't have is CE. If I needed to, would I be able to find CE? Yeah. Let's see what it's asking us for. It says find angle F. So I'm going to trace angle F. Right, do we agree angle F is an outside angle, but not a tangent-tangent angle? All right, since it's an outside angle, we know angle F will equal big arc minus small arc. Divided by 2. Well, the two arcs that it's eating, the small arc is CE, the big arc is DB. We got DB, but now we have to find CE. How are we going to find CE? Michael. Good. I'm going to add up all these arcs. 120 plus 120 is 240, right? 240 plus 70 is 310. So then we get 50 degrees over here. So angle F is going to be 70 minus 50 divided by 2. So how many degrees is angle F? 10 degrees. Mm-hmm. I actually want to do number 7, and then I'll go on to number 9. All right, so here we have find x and y. Let's start off with x. So here's x, and now this is an inside angle but not a central angle, right? Inside angle but not central angle. So we want arc plus arc 1 plus arc 2 divided by 2. The problem is arc 1 is CE, arc 2 it's the arc vertical to it, which is BD. I don't have any of those. So I have a problem. All right, so now what I'm going to do is, knowing I'm going to have to find arcs, I'm going to go and say, okay, well, let me start with some numbers I do have. What number do I have? I know I have a 40 degree here. What does that 40 degree belong to? What does that 40 degree belong to? Oscar?
Arc CF. Oh, C.
Nope. It doesn't belong to an arc at all. So that 40 degrees is labeled for what, Oscar? Like it's not an arc, it's labeled next to what? An angle, right?
Angle B.
Angle B. All right, so angle B is 40 degrees. Do we all agree that angle B is an on angle? So we have angle equals arc divided by 2. That on angle, angle B, or that on angle, is going to be 40 equals arc divided by 2. Now, if you trace angle B, isn't that arc CE? So we're going to say 40 equals arc CE divided by 2. Multiply by 2. Arc CE is equal to 80. All right, we got one arc that we needed. Now we're going to go to the only other number given to us in this problem, which is 20. What does 20 belong to? What does 20 belong to? Mia? I'm sorry?
Well, it belongs to
Angle E, you got it. So angle E, let's trace it to see where it's touching the circle here. Well, which arc is it eating in this circle? If you wanted to extend it. From B to D. So once again, E is an on angle. So angle equals arc divided by 2. So 20 degrees is equal to dB divided by 2. So multiply by 2, arc dB is 40. Now we have everything we need to find angle X. Angle X is an inside angle, so go back up here. It's going to be 80 plus 40 divided by 2. So angle X is 60 degrees. Now let's go to angle Y. Do we all agree angle Y is an outside angle? So angle Y is going to be big arc minus small arc divided by 2. The big arc is 80, the small arc is 40, so angle Y is 20 degrees. right, now let's go to that monster one. Are we ready for the monster? Who said wait? Wait. Like there, wait? All right. All right, ready for the monster? Just take it one step at a time. Don't get overwhelmed. So it says find arc AB. Well, the first thing I notice is that AH is what? What's AH in reference to the circle? A diameter. So what does that mean? From A to H on this side is 180. And from A to H on the other side is also 180. That is going to be super helpful to us because when it says find arc AB, well, isn't that the last part of the diameter, like the semicircle? So it's just 30 plus 50 is 80, and then 80 minus 180 is 100. Is anybody not understand how I got arc B to be 100? We're all good with that? Oh, because a diameter splits a circle in half. So a full circle is 360. So if a diameter splits it in half, it's 180 on one end of the diameter, 180 on the other. It's known, yeah. Because the center of the circle is O. So it says circle O. So any chord that goes through the center is always a diameter. You can have multiple diameters in the same problem. All right. So now we want to find arc CD. Well, on the other side, on the pink side over here, from A to H is also 180. We have an 80 and we have a 40. 80 plus 40 is 120, which means CD has to be 60. All right, so now the purpose of the 180s is done. I can erase this marking to unclutter my diagram. All right, so now I want to find angle ABD. Follow your letters A to B to D. That's this angle right here. So I'm going to trace it. A, B, D. So I'm going to ask you, angle ABD, is it an inside angle, outside angle, or on angle? Simon, stop it. You guys can't sit next to each other. You're too distracting to each other. Inside angle, outside angle, or on angle? On. What's the formula for an on angle? Arc divided by 2. My arc is not 60. My arc is not 80. What is the arc that this angle B is eating? Not 60, not 80, but 140. So this is 140 divided by 2, which is 70. All right, erase those markings now to unclutter this. You have to memorize those formulas, yep. All right, now we want angle HED. So I'm going to follow the letters. H to E to D. Call it angle 1. Do we agree angle 1's inside but not at the center? So then we want arc 1 plus arc 2 divided by 2. Well, arc 1 is 40. Where am I getting arc 2 from? Arc 1 is 40 clearly because angle 1's eating 40. Where am I getting arc 2 from? Yep, we're going to find it from its vertical angle, so it has to be 100. Divided by 2, which is going to be 70 degrees. All right, now we want to find angle ECG. Follow your letters. E to C, not to O, E to C to G. Do we agree the vertex is C? So it's on the circle. What's the formula for on the circle? Arc divided by 2. What arc is it eating? Oh, this is sneaky. You think it's eating the 60. Is it eating more than 60? Yeah, why? Because if you take CE and go to where it touches the circle, you have to go all the way up, right? So it's not really the 60, it's the 60 plus 40 plus 30. So this is going to be 130 degrees, which is 65. Half of that is 65. Yes. Why is it also the 30, not just the 60 and the 40? Okay, because remember, a tangent chord angle, it has to be a tangent where CG is the tangent. And then it has to be made with a chord. Now, the chord starts at C, but it has to touch the other end, too. What's the other end it touches? F. That's the tangent chord angle. So even though it just says angle ECG, you have to extend it all the way till it touches the circle again. All right, can I erase this marking? All right, B-A-H. Follow your letters. B to A to H. Do we all agree that's an on angle? It's not eating 50, it's not eating 30. What is it eating? 80. Half of 80 is 40. And the very last one, angle OCG. OCG. Didn't we already do this one? Or no?
You did ECG.
Oh, we did ECG. Okay, sorry. OCG. Oh, this is super sneaky. Guys, what is OC in reference to the circle? What is it called? A radius. What, and isn't CG a tangent? What happens when a radius touches a tangent? Right angle. So this is 90 degrees. That was sneaky, right? All right, we are done for today.